Our next presenter is Dr. Brian Palik, and Brian is a science leader for the Applied Forest Ecology with the USDA Forest Service's Northern Research Station in Grand Rapids, Minnesota. Forgive me. Brian earned his Ph.D. in forest ecology from the University of Michigan, along with serving as adjunct faculty with multiple institutions of higher learning. He also works broadly on questions related to the ecological sustainability of managed forests through use of operational scale and long-term silvicultural research. Brian will be offering two presentations today. His first one will focus on an ecological model for fire reintroduction in an old-growth red pine woodland. Brian, thank you so much for joining us today.
Okay, thank you, Lisa. So you should be seeing my first slide and hearing me?
We are.
Okay,
yep.
Cool. Okay, so really work towards restoring forest towards that functioning ecological condition that Keith referred to. And both of these deal with red pine dominated woodlands. This first one is dealing with how fire can be reintroduced into a long fire excluded pine system. And it's our role is really from a research entity standpoint, providing some information to help facilitate this collaboration between the Leech Lake Band and the National Forest that you've been hearing about today. So what I'm going to do mostly is set the stage in terms of what red pine woodlands should look like or did look like or could look like. And then I'll get into this Sunken Lake project, which is an example of fire restoration. So first, let's set the stage. When I talk about pine woodlands in the Lake States, if you speak land fire, I'm really talking about this Laurentian Acadia northern pine woodland that occurs across the 3 Lake States and in Canada as well. And what do we know about it? What we know is red pine occurs in some abundance, oftentimes a lot of abundance, in many different types of native plant communities, habitat types, ecosystems. And what you're seeing there is a list of, it's from the Minnesota Native Plant Community Guide, the systems in northern and central Minnesota that have an abundance of red pine or mixed pine in them. And just note that there's similar ecosystem descriptions for Wisconsin and Michigan as well. It's not unique to just here. Most of our work occurs in this northern dry mesic mixed woodland, and it's the most abundant or widespread in terms of area in northern Minnesota. So what do we know about that ecosystem? Well, in terms of disturbance regimes, we know that fire was important. And mostly fire, but we've also learned that wind, blowdown, and root rots, native root diseases were also important. But anyhow, in terms of fire, here's what people thought for the longest time based on work that Heinzelman did in the north. And it's that the crown fires occurred every maybe on average 200 years fire return interval, and then frequent service fires. And I will say that Heinzelman actually never said this. It's a misinterpretation of something he did say and write and work on, but it really has stuck through the ages in terms of what people thought about. And you can see that in this description of the fire regime for this northern dry mesic mixed woodland, these infrequent catastrophic fires, frequent low intensity surface fires. So people operated under that kind of understanding for a long time. Well, there's been really great quantitative work in a number of places, but including on the Chippewa National Forest, really trying to get at what the fire regimes truly were like in these mixed pine systems. And this comes out of work that Mike Stambaugh at the University of Missouri did with us, and he's working elsewhere on this same question. And you can see it's the locations that he's worked on the chip, fire return intervals ranging from 1 to 40 years with a mean of 6.6 years, so really frequent. And there, again, similar estimates for fire and how it worked in Wisconsin and Michigan. So what that really tells us, you can't have a stand replacing fire every 6.6 years. So these were mixed severity fire regimes, including less than stand replacing fire, low intensity surface fires, occasionally intensifying to something that was disturbing the overstory. And interestingly enough, these people I list at the bottom knew this. So if you go back to the old literature, people wrote about this. They knew how these forests work, but then something happened where people seized on to Heinzelman's interpretation, and we lost track of what these things really looked like or worked like. And so here's a little bit more about how this ecosystem looked and worked. So this is reconstruction of establishment history for 7 old growth red pine dominated stands in Minnesota. And this is work Sean Fravor at the University of Maine did when he was with us. And you can see that they were really complex in terms of pine age structure. So the first circled at the top is broadly single cohort, but like a 60-year establishment window for pine. And then the one circled at the bottom is really complex, so multi-cohort age structures. And the point is that pines were regenerating near residual overstory trees after disturbance in these cases. They weren't truly stand replacement disturbances regenerating to even age stands. And these are just great photos from the Chippewa National Forest in the 20s or so that show this really kind of large gap opening based regeneration events, disturbance and regeneration events in pine. So again, not unique to Minnesota. People are learning and have discovered the same thing in Michigan, Wisconsin, and in Canada. So what else do we know about these ecosystems? Well, they're really, we talk about red pine, but they were really mixed species. And you can see examples of bearing tree percentages from different locations in the lake states. And here in Minnesota, this FDN 33A that I've been focusing on had 11 species of trees in it. And that photo shows all 3 pines in that are native pines there. So again, why? Mixed severity fire regimes, including less than stand replacing fire that created a range of conditions for different trees. What else do we know? Well, we know they were woodlands. I've been saying that, these descriptions here, most of them have woodland in the title. So variable, open canopy, not closed forest, high density forest like they're managed for timber. And again, why? Frequent mixed severity fire that created those variable open conditions. Okay, so now with that kind of background of understanding of what a mature old growth mixed pine woodland should look like, well, think about this project here. So the Sunken Lake project is a collaborative effort to restore that ecosystem characteristic through fire reintroduction. And it involves all these entities here that you've been hearing about. You haven't heard as much about the Leech Lake Tribal College, but they're involved with this. And I know there are people from the college on today. So we'll get into this project, but first, where is Sunken Lake? So Sunken Lake occurs on the Cutfoot Experimental Forest. And you can see the general location there. So right within the boundaries of both these entities, the Chippewa National Forest and the Leech Lake Band of Ojibwe Reservation. And of course, the broader interpretation of that is this whole thing is within the traditional homeland of the Leech Lake Band. So what I've come to learn over the years of working there, that Cutfoot Experimental Forest and Sunken Lake is really important to the band and band members. So a little bit more on Cutfoot Experimental Forest. It was established a long time ago, 1932. It's about 3,100 acres. It's mostly this fire-dependent dry mesic woodland with red pine dominance. And research began even in that area, began before it was even established. And really until I came along, I guess, for better or worse, it focused on timber management, research geared at timber management for red pine. And we've really kind of flipped the coin there, and we're focused much more on ecological management approaches, restoration, and climate adaptation. So then within Cutfoot, there's the Sunken Lake Natural Area. You can see that square there. And it's called Sunken Lake because of that lake there that dropped in lake elevation very rapidly. If you look in this photo in the background, that notch is an esker that blew out a number of years ago, and the lake level dropped like 15 feet within a matter of hours, hence the name Sunken Lake. So the natural area itself is a section, 640 acres. It's mostly old pine or pine hardwood mixtures, and largely there's been no management in it. Again, it's this fire-dependent dry mesic woodland that I've been talking about. Fire origin, red pine dominated. We know that the pine areas are multi-cohort in structure. I'll look at this in a minute. It's been fire excluded. Keith referred to this since the early 1900s, and it's highly overstocked. If you're familiar with these numbers and what they mean, 180 to 200 square feet per acre is way more than stocking of trees than a pine woodland should have. And it has this dense shrub layer, mostly beaked hazel. So the interpretation there that, and I really like the way Keith said this, it's not ecologically functioning the way it should or could. So what you're seeing here is in the middle is an actual sample that Mike Stambaugh used for dating from this research. And you can see the fire scars that he's tabulated on there. And then the top graph on the right is the pine cohort establishment dates. And those dates are two known fires. And presumably that earlier cohort had a fire as well. It's just, there's no record of it. And then that's actually a stem map plot from within Sunken Lake. It's just, it's not the whole Sunken Lake area, but it's a plot in it that Sean Fravor stem mapped, and you can see the intermix of pine cohorts in there. Not one age, and not not a even age single cohort kind of forest at all. Here's another way to look at it that last graphic didn't show, and it's the hardwood encroachment that's going on with lack of fire and the lack of pine regeneration. So again, this just shows the red and white pine establishment dates, and then off to the right in that tail are the non-pines, which are things like paper birch and a lot of red maple, as you can imagine. And then the bottom is the diameter distribution. So the smaller, and that doesn't show the trees under 12.5 centimeters diameter. So there's certainly a lot more of them as well. And then no pine regeneration since sometime in the early last century. Okay, so what I've tried to do is give you a sense of what this ecosystem could look like, should look like under a natural fire regime, and then what it looks like now. And that's the Sunken Lake area is just one example. It's not the only one that looks that way, with hardwood encroachment, lack of pine, overstocked. So the Sunken Lake Fire Reintroduction project is meant to try to think about getting that example ecosystem back towards that ecological functioning condition. So restoring fire to emulate the disturbance regime, reduce hardwood component, increase regeneration opportunities for pine, and promote fire-dependent plant communities. And we'll get back to that last one in a minute here. The prescribed fire objectives for the Chippewa National Forest Fire Program is to reduce fuels with planned multiple burns in burn units as they break them out here. And so if you look on this map, it's broken up into units 1, 2, 3, and 4. Units 1 and 2 are in Sunken Lake, and they, as we'll look at here in a minute, they have been burned. Units 3 and 4 are on the experimental forest, but outside of Sunken Lake. So they're younger, they're managed, and the plan is to burn those as well. And then we consider that area to the right in Sunken Lake to be a control that isn't currently planned to be burned, but we'll just follow it relative to the burning. So let's look at this idea of the goal of promoting fire-dependent plant communities. And that's really where the Leech Lake Band and the Tribal College come in. And it's via this project that was an intern project that was funded initially by the Lake States Fire Science Consortium. And it's looking at the effects of fire reintroduction in pine woodlands for important species, particularly blueberry species. And you can see the people involved in this, and I believe all of the names, all those folks are on the call here. And perhaps some of the interns from the college that had worked on this are as well. So the goal really is focusing on blueberries initially. And here's what has happened already. So there is a monitoring network in Sunken Lake and really the whole Cutfoot Experimental Forest. And there was pre-burning vegetation monitoring on that network. And if you look on that map, if you can zoom in there and see it, those little white circles are long established monumented monitoring plots that were put in starting in 1931 to 1934. And Doug Castendick, who works with my group, and he's on this call, has worked diligently to relocate as many of these as we can throughout Cutfoot and to remeasure them. And we publish some on, changes from that monitoring network. But anyhow, that's where this information comes from. And it just shows blueberries pooled, the two species, both density and then cover. And the way this is set up, this is again pre-burning numbers you're looking at here. So where it says burn, that was the units that have been burned, but sampling before the burn, then the control, then the manage. And it looks like that the managed system actually has a bit more in terms of blueberry density and cover. We haven't got to, or the group that's doing this haven't got to fruit production yet, which is, the real telling thing in terms of flowering and fruiting. But anyhow, gives you an idea what that looks like and where it's going. So just a little bit on the status of the fire reintroduction. So there was a burn last spring in 2021, and it was that unit 1 and 2 that were burned. And there was the second burn planned for this spring. But if you're aware of what's going on nationally with the Forest Service, there is a temporary ban, postponement of prescribed fires throughout the country because of what happened in New Mexico. So that burn is on hold. There's a possibility it can still happen this fall, which is actually more in line with probably when fires occur in this system. There is post first fire vegetation monitoring that just started, I believe, this week with the Leech Lake Band and the Tribal College folks in particular. So just some photos that Doug took from that burn. So that's what we know today. The other thing we do know, without even having another burn or measuring this yet, is that one burn is not enough relative to hazel and what happens to it with prescribed fire. So again, hazel encroachment is a huge problem in our pine systems that interfere with a lot of things, pine regeneration, diversity of other plant species. So there's an example. This top left is the Sunken Lake area, the burned and unburned side after one burn. You can see that. And then there's beaked hazel resprouting after a single fire. So you top kill it, but it comes back with a vengeance. And we know that that's a problem. And it comes out of another project we have on Cutfoot, which is a long-term prescribed fire study that was started in 1960 by this gentleman that's standing by that sign, who was able to visit before he passed away a few years ago. And it's season of burn and frequency of burn. You can see dormant, summer, annual, biennial, periodic, and then unburned control. And here's what happens with Cutfoot. This is after 4 burns. And the way this is arrayed is the control, no fire, dormant season fire, annually, every other year, periodic, growing season fire. And after 4 burns, they knocked back hazel. And I guess standard errors hadn't been invented yet, 64. I don't know, because they're not on there. But you can see what happens. Dormant season burning just makes hazel mad. It comes back with a vengeance. And doesn't matter if it's annual burns or not. And there's 74 remeasurement. So same thing, dormant season, not good. Actually makes it worse than the control. 11 burns. They actually did 11 burns on this study and got rid of all the hazel. There was none left. And then we remeasured this 36 years after the last fire in 2005 with students that did this. And you can see that no fires since whatever it was, 1971, and there's still a pretty low density of hazel in that summer annual burning relative to the control. Okay, so I'm going to finish up here just summarizing. Natural mixed fire woodlands are rare mixed pine woodlands are rare in the landscape, really anywhere, including in northern Minnesota. And a lack of fire over the last 100 years and timber-focused management. We'll talk about that in my second talk, what that looks like, really contribute to that loss. Where appropriate, fire reintroduction may help to restore woodland structure and composition. And I'm not getting into this, but we certainly can talk about it. That kind of restoration actually increases adaptation potential to climate change in this ecosystem. And there's really limited experience monitoring results of burning in old pine. They do some of this in Michigan for sure and other places, but here, not so much. And the Sunken Lake project provides that opportunity. And then restoration of pine woodlands is culturally important, as Keith pointed to people of the Leech Lake Band. And so this partnership that we just try to facilitate really among the band, the tribal college, the national forest is key to moving this particular project forward. And I'll just finish up by saying I'm talking here, but these people here are the ones that are doing the work on this particular project. And Doug Kastick in particular, who works with us in our lab, has really spearheaded this effort of trying to get fire back into Sunken Lake. And he's on the call as well. So I believe, Lisa, I am done with that.
Thank you, Brian, very much. That was very interesting. And we do have a question for you and some time. This is from Shelley Hedke. We are working on reintroducing fire to a jack pine woodland NPC. And if you look at chat, there's a number there that's related, FDC 23A. Don't know if that means anything to you, on a scientific and natural area in Hubbard County, Minnesota. As mentioned, there is reticence to include fire in coniferous forests, rightly so, given potential volatility of these fuels. We're thinking about timing of fire to reduce some of the risks, but still meet site objectives. Any thoughts about sponsoring or collaborating on training days for fire practitioners in FD forest fuel types?
Well, so first of all, what I would say is, those of you who aren't aware of this, the state of Minnesota has a really great ecological classification guide, and they call them native plant communities. So that's what that NPC is. And then there's, the designations of whatever it happens to be. And they're similar to habitat types from that people in Wisconsin use. So that's what we're talking about there. And I guess I would just say that absolutely interested in helping inform. I am not a fire person, and I don't really research fire, prescribe fire. What I research is what these systems look like under their natural disturbance regime. So to the extent that that can be helpful, I certainly am interested, if that's the question.
Would you say that native plant communities are equivalent to Texas ecoregions?
I'm guessing that that's different scale. So when I hear ecoregion, I'm thinking something larger scale, like the Superior Uplands in northeastern Minnesota. Whereas native plant communities are really focused at when you go out to a particular site and stand, you key it to a native plant community. So more like ecological land type phases, if you know that terminology that some people use. So smaller scale, I'm guessing.
Okay, very good. Thank you. All right, one more. We're still in good shape time-wise. This is from Carly Lapin. Are you aware of any sites where mechanical treatments are being used to control or reduce hazel instead of fire? Any ideas on what works?
Yes, well, absolutely, I'm aware of it. So the Chippewa National Forest, and there's people on here that could speak to this, use something called a harrowing device, which is kind of like, plow discs or whatever they're called, harrowing discs on a skidder. And they break up the hazel roots, and it creates a mineral soil furrow that you can either plant on, or natural regeneration seeding occurs on. And it does reduce hazel for a number of years and provides more opportunity for regeneration. So I'm aware of that. They've done it for us on multiple projects, and I'm sure there's other groups that use other mechanical means. I guess I would also say we have a long-term project in pine where we manually removed, knocked back hazel with brush saws over pretty large areas, like 40-acre blocks, and over a number of years. And you can reduce hazel density over time by doing that. Probably 1 or 2 times isn't going to help, but multiple times knocks it back.
Okay, very good. I'm going to save Rick Horton's question for the end. That's a good one.
Yeah, Rick's question wouldn't be easy to answer. I can anticipate.
Folks may want to find that one. That's a big one.
Yep.
Okay, great. Brian, thank you so much.